Welcome to the Making Math Moments That Matter podcast. I'm Kyle Pearce.
And I'm Jon Orr. We are two math teachers who together,
with you, the community of educators worldwide, want to build and deliver math lessons that spark engagement,
fuel learning,
and ignite teacher action. Welcome to episode 3. Are you ready to make math moments that matter?
I am so ready. Let's dive in.
Today, we are sharing 4 go-to tools to fuel sense making in math class. Here we go.
Hey, Kyle. How are you doing tonight?
I am doing quite swell, my friend. How are you?
I'm pretty good. Let's start off like we did last episode. What is a quick math moment win for you today? What was going on today?
Oh, for me, I was working in my district, Greater Essex County District School Board, and I had the pleasure of working with about 30 kindergarten teachers on math. God bless their souls. They are working so hard with all of these young children. I mean, hilarious moments in a kindergarten class, but boy, oh boy, it is a busy job. So hats off to them. We had an opportunity to dive deeper into the 5 mathematical proficiencies. Our district is going through, we're in the 3rd year of our math strategy after we had a math task force. And we've set our sights on really trying to better understand what makes students mathematically proficient. So we had some pedagogical documentation there and spent a significant amount of time exploring the principles of counting and quantity, as well as a guide that I had created originally up on my blog. You can actually access it. Anyone who's interested, if you're teaching in K through 3, but I would argue that even teachers in middle school really should understand how counting develops. You can access it at makemathmoments.com/counting. But boy, what an amazing group of educators who came hungry for content knowledge. It's not every day when you have teachers wanting more discussion about counting principles like hierarchical inclusion. It was awesome stuff. How about you, Jon? What was your quick math moment win for today?
Yeah, today in my grade 9 and my grade 10 class, we did one of our weekly portfolio days. Which is, it comes down to, like, we make a point right from the beginning of the year to put a main focus of what we do all day, every day in those classes to just get better at math. That's a big mindset for us in those classes, is how can we get better at math? That's our main goal. And when you think about it as a teacher, how often do we make that actionable in our classrooms? So much of what I used to teach and the way I used to run any sort of assessment day or lessons is like I taught a lesson, and then I taught another lesson, and then another lesson, and then we had a review day, and then it was a quiz or a test day, and then we moved on from there. Whereas what I do right now is we designate one day a week to working on improving our understanding on any previous learning goal. That's one day out of the 5 days where we're going back and we're fixing up any of the work that we had done before. I have this idea, I don't want them to accept that, if they got half of it right, that's okay. I want them to always have like the perfect, so that when they look back through their notes, it's always right. I want that. I want them to show that growth in that striving for accuracy is also important, and what we need to show that we value that to our students. So I designate one day a week to making that happen, and it sounds like a lot, but I'd actually save a ton of time when I have this one day a week. Now we're gonna dive into like what that looks like in a full episode coming soon to you. But if you want to know more about that, if you're interested in what those portfolio days look like or how I organize them, you can learn about those right now at makemathmoments.com/portfolio. That's makemathmoments.com/portfolio. But for my win today, I love these days because they're always great. I love seeing the improvement and the understanding. They feel a sense of accomplishment on these days. And, the best part, it's all customized to the student. Not everyone is doing the same thing on these days. It's very much customized to what they need to work on. And it's a highlight of my week.
That's awesome. That's awesome, John. I was actually going to ask you, to elaborate on that. I was going to ask that question and say, so is this something where, you control what they're all working on? And I know the answer to that because, both you and I were experimenting with this idea a couple years back, and I'm sure, you've modified how you're doing it in your class, but I distinctly remember this as like a game changer for me as well. Just giving kids this opportunity. And the thing is too, is not only are they going back to try to improve a learning goal, but you're also assessing it and using that to impact the evaluation. Be it that next midterm or at the end of the course, like it actually matters. So students know that, they're not only getting better at the mathematics, but they're also getting that reward of, my assessment or my grade is actually more reflective of what I currently know instead of what I knew, 3 weeks ago when I wasn't doing so hot.
Yeah, right. Like our big thing is that everything in the course counts. Kids will always say like, does this count for marks, sir? And I say everything counts, and those days count. Everything is going to count towards your learning. And I want to take all of that if I had to give an assessment. And I always say like, we might do a quiz on that day. And the kids will want to know like, oh, how did I do in the quiz? And in the quiz, I always tell them it's a snapshot of what that learning is today. It might change next week. And that's the great thing about those days is that we're always improving at our learning, and I record and track and help them see that growth every week. So great. Those are, as I said, they're my highlight of every week.
That's awesome. That's awesome. And I know, it gives you, I remember it giving me time to actually go and sit down with some students and do a little bit of that small group instruction that I know from the secondary perspective, we all struggle to try to find the time to do. So it really, it's kind of a win-win there where you get an opportunity to sit down with some students and really try to, intervene and address some gaps that are there. And maybe sometimes students aren't too sure what to do about them. So awesome stuff there, John. Thanks for sharing.
Yeah, no problem. We got a lot of stuff to cover today. Right, Kyle?
Yeah, we do. In episode 2, we introduced you to one of our most used, our most consistent tool for sparking curiosity. That was the Curiosity Path. If you did not listen to that episode, you definitely want to go back because this is, the thing that I would say you and I in particular spent the majority of our, careers to date really focusing in and honing in on this idea of like, how do we engage students? So, we had this focus on withholding information to build anticipation, empowering student voice and choice through Annie Fetter's Notice and Wonder protocol. And we talked about how we try to give students an opportunity to put some skin into the game by having them estimate or make predictions before unleashing them on a low floor, high ceiling task.
Right.
So what are we doing today there, John?
Today, we're going to take some time and we're going to chat about how can we ensure that all students are able to access the math. When you think about when we talked about sparking curiosity, we were generating this mystery about how we can do the how we can get into the math, and we got a lot of engagement out of that. But then how do we keep the learning going? What are we doing in our class to promote deep thinking about the math that we're coming? So we're calling that the fueling sense making. And what we've got for you today are 4 go-to tools that we can implement on a regular basis in our classrooms.
And, we did reference it back, I believe it was episode 1, when we addressed this idea that, we had spent so much time and especially as secondary teachers, I bet you anybody in that, grade, I don't know, middle school years, like grade 7 to 12-ish would probably relate that it's almost like we are so hyper focused on engagement because so many kids are disengaged that we sort of lose sight of why we're trying to engage them in the first place, which is to help them understand the mathematics. So it was like once you and I sort of got, felt like we were starting to get somewhere with sparking curiosity with our students and developing this idea, this curiosity path to keep kids interested in leaning into the math, we realized that, oh my gosh, now they're interested, but they're still not really making connections in the math. And that's because we were like kind of leaving all of the math behind, just so hyper focused on that curiosity. So that's kind of what we want to talk about today.
When I think back to how I was teaching lessons, like I mentioned earlier, we generated all that curiosity, and then I'm just going to go back and I'm going to pre-teach, or I'm going to teach these lessons the very traditional way. And when I do that, like I'm doing all the thinking. We talked about that in our episode 2 also, that, when you're teaching from examples and you're doing all the talking and walking kids through. And you know what I mean by doing all the talking, because I used to be the teacher that said, I'm doing my examples as my lesson, and I want to have student engagement with that lesson. So you would ask questions to the kids, and the questions I would ask would be very trivial type questions so that they would feel success. Because I did not want them to all of a sudden be wrong in front of everyone. You know the questions I'm talking about. Like, we're doing a calculation on the board, and I just asked someone to multiply, and all they have to do is get their calculator. And half the class was lost, and the other class are with me. But the kids who are with me are like, yeah, they were just going to multiply, Mr. Orr here. Well, really? Do we really need to do that? So like I was doing all the thinking, walking them through the strategies, and they weren't doing any of the thinking. They're just not really attempting it themselves. So like where was the actual thinking? And what we want to do here today is the techniques on how we can make that happen. Like what can we do to help students develop that deeper thinking during the lesson, and almost take you as a teacher out of that role of being the one that gives them everything to do all the time.
Well, it's interesting too, John. Today there was a great discussion. One of the kindergarten teachers I was talking with, and they were sharing out to the whole group, was referencing like something as basic as like at an early age, like when you're 4, when you're 5, when you're 6. Even just like doing everything for kids. So like I'm picturing you in your math class, and, you doing the examples, and then you're just throwing up these lob balls like, hey, somebody, help me out with 7 times 3, right? And, the kids who don't know their math facts can't put their hands up. And then the ones who don't want to do it because it's so obvious to them, there's no engagement. It's very similar to like these kids in kindergarten who know how to put on their coat, but yet, mom and dad always do it for them, right? So it's like, they made this parallel to how, oftentimes like we don't allow kids to do the work, whether it's like physical work of like, putting their shoes on and trying to help them learn how to tie their own shoes, or, later on when they're in a high school classroom where it's like actually doing the thinking. So when we get into these 4 go-to tools, the first one we want to talk about is this idea of concrete, like thinking of using concrete tools, concrete manipulatives, because there is this developmental continuum of like starting with, things that are tangible, like in the real world, things I can touch and feel and manipulate. This level of abstraction that we're asking kids to do in math class without having something to like touch and manipulate and move is really, really difficult. So like the concrete manipulatives looks very different from class to class to class, but really all it is this idea that when we're starting with a new idea or something that, we're trying to increase our depth of understanding, we want to go back to the concrete to make sure that students get that conceptual understanding, whether it be counting in quantity and students counting objects like sets of objects on the table, or whether it's students like multiplying 2-digit by 2-digit and actually using base 10 blocks, or whether it's kids in, in algebra 1 or for for us, grade 9 and grade 10 here in Ontario, for them to be working with algebra tiles to actually physically manipulate, like concrete manipulatives, is such an amazing tool that I did not use for the majority of my career until
Right.
I finally had that epiphany that, oh my gosh, this stuff is not only helpful for the kids, but I'm going to argue that it's like necessary for them to
Right.
do this, because not all students can visualize and be able to make those connections between the concrete and the abstract or the symbolic notation that we use in math class every day.
Right. Right. Like I'm thinking about, like, there's this huge misconception that if, and especially in high school, that if you need to use manipulatives, you're operating at a lower, or lower functional thinking level than someone who doesn't need those manipulatives, which is completely false. We've got, like, like, there's the future of learning, and the future of higher level learning is done so visually, and so much of us learn visually, not abstractly. But when I'm thinking about teaching those algebra concepts in my grade 9 and grade 10 class, I used to always just go straight to the symbolic representation of what was going on in class, like 3x plus 6x. And how many kids are making mistakes on what x plus x is. Some of them are writing x squared. Some of them are doing, when you're doing x times x, they're writing 2x, and they're not sure why. And these are the issues when they come out. We're like, why am I ever going to use this? They just don't see what's going on, because they just see these symbolic, abstract representations of things, have no point, and they just don't get the idea of where that comes from. It's huge. It's a huge thing that we've got to address. And I want to make the case that it's not for kids that are weaker that should use these manipulatives. And I was the teacher that thought that for a while. As I said in our first few episodes, and I was the traditional math teacher for years, the traditional high school teacher. That it was that teacher that you had as your teacher. That was me, and I had those thoughts that if you need to use these manipulatives or these algebra tiles, you can, but we want to do this thing over here. And when I made a conscious effort to change, to teach all of my algebra concepts for all of my classes through concrete manipulatives, this is where I had the most success with those students. I had higher level students, completing the square in their heads. I had never seen that before. That you took a complex algorithm of completing the square and trying to teach it to a kid. That was the skill that was made the most mistakes on for classes. And now all of a sudden you got kids completing squares in their heads. I was sold.
Right.
I was sold right there, and thinking, like, this is something that we need to be doing all the time. Concrete manipulatives are a must for our making kids understand our math.
Well, it's funny, I'm listening to you, and you had mentioned, I originally thought that same misconception about, students who quote unquote need the manipulatives are the weaker students. And, I am going to just go and say on record, it was like well over half of my career that I had that understanding or misconception, I should say. And the real reason why was because I didn't understand how to use them.
Mm-hmm.
And that's something that, I never want to blame teacher, point fingers, because the reality is it's not like we taught without manipulatives because we knew that what they were useful for and opted not to because we just didn't want to help our students. I just had no idea how to actually use them. And the part that's really hard to break in a classroom is this idea that, like, you got the bin of manipulatives in our district. We have this big tub that every elementary class gets one. And, it might be a big yellow one, or like if it's an intermediate kid, it's a red one. And it goes in the class. And it's like, if that tub sits on the shelf and the instructions, like my instructions to the student is, whoever needs manipulatives can come up and grab them. Like in my mind, I might be thinking what I'm saying is like, yeah, like everyone can use them. But like what a student's hearing is like anyone who walks up there is doing the walk of shame to go grab those manipulatives because I need them and nobody else does. And I'm going to argue that there's tons of kids in that class that are using symbolic notation and procedures, but they, like you said, they have no idea what they're doing. Like when I'm adding or multiplying and I don't know whether I'm squaring or if I'm adding the coefficients, I have no idea because I've never seen it in the real world. And the kids who get the advantage are really just the kids who have like the, that skill, that memorization skill that I know for me, speaking for myself, that's what got me through school as quote unquote a math guy. And I got a math degree based on the fact that I could memorize stuff, but I had no idea, like no conceptual understanding of the work that I was actually doing in class. I don't know if you feel the same way there, John, but I know tons of people that, we were the lucky ones because we managed to be able to memorize enough to get us to that place that got us, into college or university or into the program we needed, whether we felt we were math people or not. It was
Right.
like we had enough to get us to where we needed to get to. But not all kids have that luxury of having a really good memory for just memorizing straight up.
No, I was exactly in those shoes, same as you, and it wasn't until I started teaching, and I think as a lot of us, it's not until we start teaching math where a lot of things are clicking, and that's something I want to change for my students. Is I don't want them to be that person that realizes later that that these concepts were more clear than they were. Like there's two examples where this was very clear for me as a teacher, but I didn't know anything about it as a student. One is the Pythagorean theorem, and I don't know if maybe you had a better teacher than I did when you were in school, but I memorized the Pythagorean theorem as a squared plus b squared equals c squared. Uh, and c squared was always the hypotenuse, and that was it. It was just completely algebraic. Yet it wasn't until I started teaching where you actually could do the geometric visual representation of the Pythagorean theorem and build squares off the side lengths of those uh, of a triangle, and see that the areas of those two smaller squares add to the bigger square. Like that blew my mind
Yeah.
as a teacher.
I was teaching when I had that revelation. I was like, "Oh my gosh, I've been teaching for years just doing it just like you said." And I had
Right.
no idea. Like it wasn't like I tried to figure it out and I wasn't like, keen enough to figure it out. It was just like I just thought like all that mattered was this formula. So I just
Mhm.
never thought to think of like where it came from.
Right.
And that was like completely a misguided way for me to approach teaching math.
Right. And think about fueling sense making. And once, I when I taught only using the formula for many years, kids are making mistakes on when do I add the a squared and the b squared, and when do I have to subtract, and when I'm finding the length that's shorter. Like there was always mistakes there, and they consistently made that mistake over and over again about finding the shorter length, and when we started, first started with concrete manipulatives, we would have a triangle to scale on our desk, and we'd start to fill in the squares off the sides with counters. They're actually using the exact same number of little tiny unit squares, and then move them around to the hypotenuse and fill in the exact same number of little squares to fill on the other side. Like they actually see that. When you start to do the reverse, like say I have the area of the larger square to start and I have to find the smaller square, like they know to subtract. Like you can clearly experience with with the little counter tiles, or when you're drawing a picture, the visual, you can clearly see that you do need to subtract these areas so that you can find the length, and
Right.
all those arrows
It's
started
like so
dropping away. Like
obvious.
yeah, and that's when we're talking about this fueling sense making. We're trying to take away, like, and they help with those mistakes, like the kids are seeing why things work. And these are things that I just memorized. I didn't, I
Right.
memorized, hey, I'm finding a short length. I do this instead of actually understanding why I should subtract.
Right. And something really interesting to make a link down for some of our teachers teaching in the younger grades. When I'm working with my primary teachers in the district, we talk about, as I mentioned, counting and quantity, but then early addition and subtraction. And I mean, the same issue happens there, even though in primary classrooms, I'm going to, hats off. I think they do a great job in trying to make things concrete and make things visual for
Mm-hmm.
their students. But in many cases, like we're still kind of get caught in that trap of, putting the anchor chart up on the wall, and it's like these words mean addition and these words mean subtraction, when in reality you could take any of those words and rearrange the sentence to make it one or the other. And that's what gets kids on these standardized tests here in Ontario, EQAO, or if it's PARC testing in the US, or whatever jurisdiction you're in. The reality is, like, this is something that's not just happening in the middle school classroom or in the high school classroom, but it's happening early on when we're teaching kids to memorize terms that mean one thing, or telling them that you add or subtract or multiply or divide when you see key words, rather than having a understanding of the situation, of the context of the problem, and being to attack it with concrete manipulatives and useful representations, which I think is a good segue for us to jump
Mm-hmm.
into our second go-to tool, which is this idea of using multiple representations, not only as a tool for thinking, but also a tool for representing and sharing, to communicate our thinking in order to make connections, so that we can build like a solid foundation, like a solid conceptual foundation, so that we can eventually build procedural fluency without just blindly memorizing steps and procedures along the way.
For sure, for sure. Like, in my classes, showing kids multiple representations, having them write out the different ways to represent a particular topic has really changed the way things are going in my room and the success kids are having. They, when I'm talking about linear relations on writing tables and graphs and equations, when I would normally teach, or normally, I mean, my past self would teach this. I'm thinking, very traditionally units. It's okay. We're going to start with graphs, and then we're going to move into, or start with tables, and we're going to move into graphs, and then we're going to move into equations after that. Whereas now, I like to start with a lot of, I start kind of in the middle, and then we move this way, and then we come back to graphs, and then we move into equations, and then we go back to tables. Like, showing the connections between the representations is huge. And that it's not just for that; it's for all the different topics, and it's definitely something that we need to do more of, so that kids can make connections amongst those themselves. And I think that's the big thing is that you can show them all you want, but it's the fact that they see it over and over again, that they will start to make the connections themselves.
Yeah, no, you're absolutely right, and something that I think may resonate with folks listening is, oftentimes we get challenges. You get emails. I've been receiving emails, or we see tweets on Twitter and things like that, where people are saying like, my kids can't problem solve.
Mm-hmm.
And you hear in the media, like it's so interesting how in the media and the politicians, they all push for this idea of back to basics, like kids don't know their math facts as being the big issue. But then when you talk to educators, usually the big issue isn't those like basic calculations. It's problem solving, where students have to actually like think to do something. And what we're finding in our district, like our math team, I've got a great math team. Yvette Lehman, Andrea Lewis Longmuir, Shelley Pike, and Angeline Humber are all part of our math team at Greater Essex. And what we notice when we go and work in schools and sit with students is, we see the students who struggle with problem solving are the students who tend to know like the steps and procedures, but they only know one way. Like they're not
Mhm.
strategically competent. They just know the way the teacher showed them. And if they don't recognize a problem as being solvable with that particular strategy, then they're out to lunch. So it's like they lack the tools and representations in order to actually like take the context of the problem and actually use a tool for thinking, not just
Right.
to like explain the answer they got, but to be able to use it as a tool to help them get to an answer. They just sit there and it's like, they're just spinning their wheels in the mud. And often what that leads to over time is you see more kids that disengage completely and just leave questions blank. You
Right.
see like that blank question. And we're always asking to teachers are saying like, why didn't they even like give it a shot? And they kind of, it's easy for us to maybe blame the student like, geez, Tommy never puts a full effort in. But meanwhile, Tommy's sitting there going like, I have no idea where to start.
Right.
I don't have a tool and I don't have any representation for me to actually leverage to do anything worthwhile on the page.
Right. And that, this brings up, an even bigger issue in how we structure our lessons to begin with. And going back to like kids, we always want kids to persevere through problems, and they're like this kid you're referencing is, just giving up. But what time, what part of your teaching this class or that kid, or did you show them how to problem solve and persevere? Like we assume kids come into your class and problem solving is like something that they're just supposed to naturally be good at. Like, and when you think you're going to teach problem solving, you'd say like, okay, I'm going to do a word problem. Okay, we're going to get the highlighters out, guys, and we're going to highlight the keywords. And like, if you think that's what's teaching problem solving, I think we got some issues, because problem solving is putting them in situations where they don't know what to do and helping them make those connections, helping them see the representation so that they can start and get a small win that leads to the next win and leads to the next win. Like that's a big issue for sure about kids quitting too early. And multiple representations can help with that. And teaching kids how to problem solve will help with the multiple representations.
I think you nailed it there, John. And sometimes you and I, when we get passionate, we really, are trying to articulate some of these key ideas. But again, like making sure that we don't forget that, both you and I were the guys saying, hey, get that highlighter out, or,
Right.
circle the word or whatever it was. Like we were doing all those things. And I think one of the biggest challenges we face as teachers, like it doesn't matter if you're a math teacher, what teacher you are, is that like we got into this industry, into this business to help kids. And that is probably our like worst quality. Like it's great to know that people want to help, but the problem is like we help too much. And, we do all of the thinking because we want them to be successful. But unfortunately, many times, like the success that we're perceiving oftentimes is us kind of doing the work. And then the students aren't actually like getting that learning opportunity. We've sort of taken that from them. And I've robbed a lot of kids of their opportunity to think. And boy, I'll tell you, I definitely feel remorse every time I run into students, in the first 8 years of my career and say, darn, I wish I could go back and do it again. But
Right.
I think the key is, as long as when we know better, we do better. And that's, I think the big piece for me is just like, once I knew that I needed to focus on representations, it was like, man, I had a lot of learning to do and I'm still engaging in that learning. I know you are as well. So
sure.
Something that we're going to continue to push for.
For sure. You want to move into the third big tool, go-to tool. We got two more go-to tools out of our four. And actually, I think these two tools coming up are very much related to multiple representations. What do you think?
I was going to say the exact same thing. It's almost like a part of multiple representations, but it's kind of like the next step after concrete manipulatives.
Right.
And the one we're talking about is visuals. Some call them pictorial representations. Some call them oh darn, I'm losing it now. Oh, iconic. That was the word I was looking for. So, different research states different terms for it, but it's like this stage where like students are ready to move from like this concrete representation to the visual. And actually, if people are interested in that progression to learn more about it, I reference some research called concreteness fading. Some know it as CRA. Actually, there's in Great Britain, there's some research we came across. A colleague of mine, Chris Knight, went to pre-service in Great Britain, and they called it ELPS, which was about like experience, language, pictorial, and what was the S? Symbolic was the last one in that continuum. So many different ways to sort of reference this idea. But if you're interested in learning more about it, I've got a link here, makemathmoments.com/concrete. That'll bring you to a article on concreteness fading, or CRA, or ELPS, or whatever you want to call it. But this progression. So we're going to talk a little bit about visuals here. How are you using visuals in your class, John?
Right.
Like what value are they bringing to you, and more in particular your students that you're actually teaching?
So like one right off the top of my head is one we've kind of referenced already, which follows that concrete fading model that you've just referenced. That when I introduce algebra concepts in, say, grade 10, and this is a grade 10 applied class where we're working with concepts like the distributive property with algebra and factoring, and eventually the grade 10 academic would be completing the square. We've already kind of said that I will start all of that with all of my students with algebra tiles. So that concrete start, having them manipulate and make rectangles for factoring. And then what is great, and I want to build towards efficiency with them, is that eventually students will decide themselves that they can be faster with drawing an image instead of using the tiles themselves. So they end up starting to draw the tiles instead of use the tiles once they become very comfortable with them. And then that drawing of tiles actually ends up being drawn of an area model, and they're using an area model to represent the tiles. So it's kind of like a building towards efficiency. And finally, students, after ready for that, they will move from the visual representation into a symbolic representation, which is what traditionally we would just jump to that, and
year after year.
Yeah, and my students, they're progressing through this nice very visual representation of algebra concepts that traditionally are very abstract.
Right. It's interesting, like for those listening, well, I guess if you're not listening, you wouldn't be listening.
That's funny.
But for those who are listening in, you've done a great job like describing that concreteness fading model, like starting with the concrete, moving to a visual, and then to the symbolic. And I want to be very clear, because sometimes people aren't very happy about the language of how they call it concreteness fading, suggesting like once you move away from concrete, you never go back. But it's actually an iterative model. So you're in grade 10, you're saying, and everybody in your class is starting with the concrete, and it's not like it's the first time they've ever seen the concrete. Mm-hmm. No, they've actually done this back in grade 5 here in Ontario when they do double digit by double digit multiplication. The standard algorithm can be represented using base 10 blocks in an array, which then develops into an area model, which then develops into that standard algorithm symbolically. So it's this idea that like as the complexity in the mathematics, as we move down the mathematical developmental continuum, as we get deeper and deeper, we always want to come back to the concrete to like sort of like almost like remind ourselves of like, yeah, like let's not lose our way. When you get hiking in the woods and it's like you lose track of where you are. Like it's so easy in math land to start using symbols and procedures. And then the next thing you know, you're like completing the square and you're like, how the heck did I even get here? So this is kind of like a reminder for us to always go back to that concrete, to that tangible, experience for me to go, oh yeah, this is why this works. and then we sort of move towards that abstraction again. And then as that new layer comes in, it's like, well, we got to go back to that concrete and let's do it again. So you never want to like forget, like, home base is concrete, right? Like, home base is reality. It's 3D. It's like the world around us. We don't want to lose track of where we began, and sort of get lost in all the symbols and procedures.
For sure, for sure. I'm just thinking. I was reminded when you were talking about that there's you've built a resource purely about math and visual representations. Do you want to talk a little bit about that?
Yeah, sure. Yeah. Actually, yeah, that I wasn't expecting to talk too much about this tonight here, but I think it's a great opportunity. A site called mathisvisual.com. If you've never been to it, definitely check it out. It's kind of put together to create all kinds of visual prompts. And, I've become pretty obsessed ever since, beginning this journey of fueling sense making and playing with concrete and multiple representations and this idea of visuals. When students are at that visual stage, like, I find that if I can like show them how it develops, and that's really the goal of this website, is to give you some visuals that are animated using Keynote and Magic Move, in order to kind of like build a conceptual understanding, make sure that we don't lose track of why we do things. So, for example, recently I had released a why the formula of finding the mean works, and we do it all. I call it concretely, but it's actually a visual animation to represent what you would do with concrete manipulatives. So that's a little confusing, but those are all there. We've got about I want to say 35 or so prompts so far. The goal is to continue just tossing up these visual prompts, and I've tried to make it so you could actually use them in class, like a Minds On, or a sort of like a number talk at the beginning of your class. So I give you some spots where you can pause the animation and give kids an opportunity to notice and wonder, and kind of play with the math themselves with concrete manipulatives or visuals themselves. So so I think that's a nice website to pair. Again, mathisvisual.com. Definitely check it out, and use anything you feel might be helpful for you and your students.
Oh, great. Let's move on to our fourth our fourth go-to tool for building and fueling sense making in our students, which is student-generated solutions or student-generated algorithms, ones that they've created themselves. This one's a big one for me, and I know this is a big one for you, Kyle. And it goes back again to that kind of multiple representations, and for me lately, I've been a big and strong proponent of the 5 practices for orchestrating productive mathematical discussions. If you want to pick up that book, it's kind of like my guide for how I structure my lessons right now. And this one's a big part of it, because one of the things that you want to do from this book is when we give kids tasks. So, in our last episode, we talked about how to spark curiosity with tasks. But once you've sparked that curiosity and got them into the task at hand, we want to not just, you don't want to show them how to do it. You want to let them show or attempt a solution. That can do a couple things. One is it's going to build that resilience that they have, because now they've got an experience solving a problem that they don't know how to solve right from the get-go. And the second is that you get to see what solutions they're going to come up with first. You get a lot of formative assessment information coming your way when that happens, and when they start to generate those solutions, you get to make those connections amongst the class. They get to fuel their sense making. You get to fuel and fill in gaps from what they're showing you. For example, like it can be as simple as taking like, for example, in today's lesson for my advanced functions class. The higher you get, the more abstract some of this math gets. And we were working with logarithms, and I know I'm scaring some people right now when I say the word logarithm, but we were solving logarithm equations, and And it was it's a very procedural type of thing. But instead of just standing at the front and saying, you know what, hey, we're going to do these 7 examples or these 5 examples, I'm just going to walk you through it, because nobody nobody really wants to do that. I have a progression of equations that are, start easy and get hard. And I put them all up on the board, and kids are working through them at their own pace, and we pause them. We pause the class to go and look at one solution and say, why did that technique work? What I love is that different students are going to come up with different techniques. And none of the and if I had taught that lesson in that traditional way, they would have seen one technique, not 3 different techniques, that we can now weigh the options of whether, this is more efficient or less efficient. And that doesn't have to be for an advanced functions class. This could be for any class where you want to look at the techniques to solve different equations. And that's for me, that's been mind blowing for me and my students.
Yeah, no, you've said so much good stuff there. I'm trying to jot down on paper here to remind me to address all of it. I know I won't be able to, but you mentioned a few things in there, and one was this idea, how you've intentionally selected those problems to create almost, like, I'm going to use the word, like a string of problems. And the reason I'm saying string is because I wanted to talk a little bit about Kathy Fosno, and she actually creates number strings, and she has a fabulous resource called Mini Lessons. More specifically for elementary teachers as well as some middle school teachers, to use, kind of like number talks, but she really has a focus on the models and the representations that she's using. She does a great job of highlighting how, why she's selecting them, and where they are in the progression, the developmental continuum. She likes to call it a landscape, like a mathematical landscape. And the reason I thought this was an interesting connection on the fly is because I wanted to reference, when I think about student generated solutions and algorithms, I am thinking about something she says, which is that she doesn't want to fix the mathematician. She wants to help the mathematician see their strategy through and try to help them seek out strategies with increasing sophistication. So, this is this idea, I used to do this all the time, where kids would do a strategy and I would walk up to them and be sort of like, yeah, that's okay, but I want you to do it this way. It's like you're grabbing them by the collar and saying, come on over here. And clearly the student's not doing or thinking along the same path that I am. And why would they? I mean, I have so much more experience. So it's like being able to take these student generated solutions or student algorithms that they're creating and trying to help them, kind of develop how clever they are at solving these problems. Another word that Kathy uses a lot, and my colleague Yvette always references. So for me, that's a big one, is this is an opportunity when we give kids the opportunity to solve problems without pre-teaching them. Mm-hmm. That we can look at what they're doing and look at their strategies. And this is the hard work, is looking at the strategy and thinking, what tool or representation can I connect their work to? So that's kind of like a 5 practices move that you'd referenced earlier. We'll put a link in the show notes to the 5 practices book. But this idea that it's like, wow, this student did this. How can I take that piece of student work to honor the thinking of that student in my consolidation, but also help to share what tool and representation might be a little bit more powerful than that original solution strategy? So just this idea of taking that work and using it to help push kids forward without dragging them through the mud to get there, right? Because we all know what that's going to do. I did it for years. I grabbed the kid's collar, we bring them over here, and now they're lost. So even though I'm thinking it's a more efficient strategy, it's a zero efficiency strategy for a kid if they have no idea what they're doing. So we have to take their most efficient strategy, which is what they just did, and try to help them kind of get to the next step in that journey, right? Hard work, but necessary work for us all.
Yeah. It's definitely not the quick route, but it's definitely a hard route. When you were just talking there, I get reminded of a situation where I've asked, that traditional class where you've outlined how to solve, say, a proportion problem. and you set up the proportion and you show them the steps to go through. You create the algorithm, with the class, and you put it up on the board. When I presented a proportion problem where I had students solve it without me showing them how to do it first, I got 3 different solutions. And what scared me about, or what worried me about me just doing it again in front of them and not allowing them to do that, like thinking the years past, is that there was probably a student sitting in my class who solved it not the way I solved it on the board, that efficient strategy, like you said. Like, I went right to the efficient strategy, and they solved it a different way. And since their way, they're solving it in their head and is not matching the one I'm doing on the blackboard, they're thinking theirs is completely wrong. And that's that scares me, because like I made that student think that. I made them think that what they're thinking was wrong because it wasn't presented on the board as right. And they would have had that connection. They're like, well, that's wrong. But even though, they had probably done some great work here, and we just have, like you said, we need to see what they come up with and then try to connect it to the efficient strategy, or just talk about how they solve that problem. So yeah, lots of good
No,
points.
that's awesome.
Lots of good points for this final one.
You sort of made me a bit sad there. I was reflecting as you were talking, and I'm going, yeah, like how many kids did I make feel that way, right? And they're not raising their hand to share. They're like, oh, gee, I'm gonna erase this now. So yeah, like we have to be hypersensitive to that. So as we're looking at these 4 tools that we're outlining. These 4 tools are pretty big. And I wrote down a note here that I never got to, but earlier you were talking about, how you started concrete with this idea of like factoring in grade 10 and working with algebra. I'm going to argue I see the exact same progression in a grade 5 class when they're learning how to do double digit by double digit multiplication. Like it's almost identical, right? Like you swap out the base 10 blocks for algebra tiles. Like it's the same stuff going on. And something I wanted to make sure that we mentioned was this idea that, like, not only was it a misguided or a misunderstanding, misconception that using manipulatives was for students who struggled, but I'm at the point now where I'm finally realizing that kids in my class who cannot represent it concretely are not mathematically proficient because they don't know what it is they're doing. If they're doing the symbolic representation and they can't show me a visual or they can't show me a concrete representation, they're actually not proficient. But like in my old mind, I would have said the student who can do it with concrete manipulatives only. And then there's a kid over here who can do it only with symbolic representation. Like, let's say if it is double digit multiplication, using the standard algorithm. And this student over here is using base 10 blocks. Like in my mind, I used to think that the kid who used the standard algorithm was like more proficient, meaning like gets a higher grade. And what I realize now is they get probably the same grade, and it's not that good because they don't have a complete they're not proficient with this process. And that's what we're really after here. We want kids that are proficient, mathematically proficient, as described in the Adding It Up document, which, we'll do an episode about that. That's a whole other story. But that's something I wanted to make sure we highlighted. It's not just like something we do to get to the symbolic and that's it, and then we leave it in the dust. It's like a necessary step. And if we're not doing that, then we're actually hiding connections in mathematics from students. And that's not to make anybody feel bad, because I was there. I totally get it. But it is to make us realize that, hey, like we've got some work to do. And I know I still got a lot to do. You got a lot to do. But we do need to do that work. And it's got to be something on our mind for sure.
Right. For sure. So let's do a quick recap here that we wanted to give you 4 go-to tools to fuel sense making in your students. Sparking curiosity is not enough. We need to fuel their sense making, and these are just 4. There's many different ways you can fuel sense making that we didn't even get into today, but 4 that we think very highly of. The first one we talked about was concrete manipulatives. Getting that concrete down before we move to abstraction or symbolic representations. The second one we had was how can we use multiple representations to fuel sense making. We talked about visuals, which is our third go-to tool. Like visuals will help with fueling sense making. And the last one we just finished talking about, which is student-generated solutions or student-generated algorithms and how they can be used to go deeper and fuel sense making with our students.
Whoa, like that's like a lot of content today. I'm looking at the time on our recording, and
we're getting close.
Yeah, hopefully, if you're still with us, that means that's a good thing. That means that you're in neck deep, not even waist deep. You're like neck deep with us, which is amazing. So again, this is like the second part of the 3-part framework. We talked about sparking curiosity in the last episode. Today was fueling sense making. And again, this isn't like everything in it, all the things that we want to do with fueling sense making, but just like 4 big ones that we want to focus on. In the next edition or the next episode, we're going to be looking at igniting your teacher moves, which is the third part of that framework. So we're going to give you a little summary of that. We have been having a blast with these first few episodes. I can't believe we got 3 in the bag already. And this next episode will be, I believe it's going to be the last one of just you and I going back and forth, because, we're going to be talking with some others in the math space, doing some interviews, as well as we're going to be working with some other math educators who have been in touch with us over the past couple of years. Some of them that have taken our online workshop that would love to come on and really just kind of riff on some ideas about a challenge in their math class, or a question or concern that they might have. And we're going to try to kind of build on the collective knowledge of all 3 of us when they show up, and hopefully that'll help some people listening as well.
Yeah, I'm really looking forward to having those people on this podcast. So in order so you don't miss it, to miss out on those episodes, they're going to come each week. So be sure to subscribe on iTunes or Google Play or Stitcher, wherever you get your podcasts from, whatever you prefer to use. Also, if you're liking what you're hearing, please share the podcast with a colleague and help us reach a wider audience by leaving us a review on iTunes. Show notes for this episode and links that we've talked about can be found at makemathmoments.com/episode 3. That was makemathmoments.com/episode 3. You can also find Make Math Moments on all social media platforms and seek out our free private Facebook group, which is called Math Teaching and Learning K-12. Just type that in Facebook. You can join that private Facebook group. We chat about lots of different things in there. So that's coming up for sure.
Awesome. Yeah. So again, as we said, episode 4 coming to you right away. So stick around for that. We're going to be going through igniting teacher moves. It's going to be a doozy. And I'll be honest, John, it's going to be tough to do it justice in one episode, but we're going to do our best to kind of, skim the surface on it, get people thinking about it, give you some resources to go and, kind of chew on. Not interested in waiting until then? Why not watch our 4-part video series to help build resilient problem solvers who don't want to stop learning math when the bell rings? You can find that free 4-lesson video series at makemathmoments.com/lesson 1. That again is makemathmoments.com/lesson 1. Well, until next time, I'm Kyle Pearce.
And I'm Jon Orr.
High fives for us.
And high fives for you.